So, welcome back. Apparently you guys really like this series because I've been getting more traction on my videos whenever I talk about GDB and LLDB. And I mean my most viewed video is about GDB, which always makes me really happy because the video is still gaining views, and my other videos they kind of just, plateau after a while, but it's still gaining views. Really happy about that, by the way. So I decided to kind of finish off the series with a video on LLDB. Now, I say finish in quotes because I'm probably going to get a suggestion that makes me really want to do another video, and I probably will if I get a good suggestion. So, because I didn't expect the GDB video to be a two-parter, let alone a three-parter, but this one, maybe somebody gives me a suggestion for a new video for LLDB and I'll record more. But enough rambling. I would like to go over LLDB. Now, LLDB, okay, this is just speculation, but LLDB kind of has two forms of commands, I'd like to say. One is the LLDB way of doing it. Like, they're much more verbose. Like, to set a breakpoint, you do breakpoint set /n and the name of the function, while you can also do b in the function the same way you do it in GDB. Since most people are familiar with GDB, I feel like LLDB has both of those styles of commands. I'll actually show you guys. Let me compile this program first. If I do, let's actually make this a little bit like right here. Okay, let's do breakpoint set /n name. This works, but if I do this and do b main, this also works. So this is one thing I've noticed with LLDB is that they kind of have both flavors of commands. Of course, some things are very different, but for example, right now it's actually the UI or TUI or whatever is a lot cleaner because it shows you the arrow, it underlines. It's really neat. So we can use the similar commands from GDB and just do /n to move to the next line, and we can do PA to print out stuff. We can do P with a format like X printed out. We can do PB. We can do like this frame variable. This will print all the variables on the current stack frame. We can actually put in a specific variable too, which, I mean, it really doesn't look too different from this. It just has the, oh my bad. It just has that little bit of a difference in the way it prints things out. Other than that, it's not really that different. So P works, N, and like R for running, C for continue, all that stuff works. And let's continue and let's step into a function. We can do it by doing S, and we can step out of the function by doing finish. And let's do N, another N. We can also do BT for a backtrace. It's very similar. I'm trying to think of another command that I can do. Oh yeah, I can do DI, which will show the disassembly. And I can't read ARM assembly, so this looks like gibberish to me. But if you can, have at it. Now, another thing we can do is, actually, let's kind of continue and exit the program. Let me think. We also have, sorry, I'm trying to remember what I can go over and what I should skip. We can also read like random locations in memory. I don't know, let's do like 8. The count is going to be 8 and hexadecimal of like a Q word at whatever the stack pointer is, %SP. Huh? Is it G? Yeah, it's G. So we can read memory at a specific memory address, which is the stack pointer. Yeah, I don't know what else I can go over, but it's relatively similar, at least the commands that I've shown, because the LLDB one is like memory read or something. It's really verbose. Yeah, it's like that, which, I mean, there is a difference between these, but it's like the more GDB style and then the more LLDB style. Maybe I'm wrong, but regardless. But with that aside, I do want to go over another really cool feature. I'm going to make this a little bit smaller so it can actually fit on the screen. If you remember from the last video, I did go over, on one of my last videos where I went over the GDB TUI, but the LLDB TUI is a lot more sophisticated, and it looks really depressing because of the color scheme. They could have really done something a little bit better, but they didn't. So let's actually leave it for a second. Let's do escape and let's do break main, and let's run the program, and then let's do GUI. As you can see, we have the code here. If we do the up and down arrow keys, we can go up and down, but it's really hard to read, I'm not gonna lie. On the right is the threads. As you can see, it shows you the process ID, the thread, and the thread ID, the number, and also shows you a little bit of a backtrace. On the bottom are the variables, and if we hit tab, we can cycle through the windows. If we hit tab to the bottom one, we can actually hit the right arrow key to expand the example and see the individual members of that structure. And of course, the regular commands work, like we can do N to go to the next one. Sorry, you had to highlight on the source to do it. And the updated variables will highlight in red. So it's really cool. Then you can mess around with F1, F2, F3. You can attach to a process. F4, step in, registers. Actually opens up on the bottom. We can tab over, and these are the general purpose registers. Damn, they have a lot of registers on ARM. I'm like totally unfamiliar with ARM assembly, so yeah. And then we can do F5. There's breakpoints also. There's backtrace. Yeah. So this is a really cool UI. You can do F6 for GUI help if you do need something like to, I guess, like a refresher. So yeah, let's exit GDB actually. Exit the GUI and exit LLDB. So that's it. And if you guys would like me to go over something else about LLDB, let me know. But I don't really have anything else I could go over. I probably forgot like half of what I was supposed to go over. I have really poor memory, by the way. Like, I can't remember anything. So please let me know if I forgot something that I should have gone over. I will make a part 2. So yeah, that's it. Hopefully you guys liked the video. Let me know what I should do next. Anyways, thank you guys for watching.